Welcome to Beyond the Comfort Zone, talking shit with King-KAMBUF. Today we are opening a file on what has to be one of the most intense, high-stakes documents we've ever analyzed on the show. This isn't your typical project proposal. This is an urgent, highly technical command brief. It's issued directly to architecture and engineering teams on the ground. We are getting into the KAMBUF National Building Design Command Brief and National Projects. And this was prepared by the services of King-KAMBUF PS Architecture Design Studios.
That's right. And this document is a blueprint for action. The date on it is Friday, November 21, 2025. And that date is important because it captures the exact moment a vision, a really big vision, translates into material, quantifiable engineering demands. It's professional, it's visionary, and it really skips all the fluff. It just delivers these precise technical objectives, and they're all designed for one thing: reinforcing national control over economic flow.
Okay, let's unpack that right away. The mission statement, the theme that's guiding all 10 of these massive schemes laid out here, is transit and logistics sovereignty for KAMBUF city-states and diaspora gateways. So we're talking about building these huge integrated corridors, rail, BRT, ports, dry ports, freight hubs, the works. But the language they use around the movement itself is, I think, really paramount. They use words like dignity, speed, and control.
It's fascinating, isn't it, the way the brief actually engineers the definition of sovereignty itself. It decouples it from the traditional political idea of a border and attaches it directly to logistical control.
Right.
If you, as a nation or city-state, own and efficiently manage the arteries of your trade, you are sovereign. It's that simple. But if that movement is slow, or it's undignified, or it's controlled by, say, foreign entities, or just chronic congestion, you lose sovereignty.
You're bleeding power.
You're bleeding power every single day. And this is all explicitly tied to unlocking regional trade, specifically under the AfCFTA framework, the African Continental Free Trade Area. So logistics ownership isn't just about being efficient. It becomes the foundation for sovereign economic prosperity, for national agency.
So the goal isn't just to, patch up some roads or build a new port. It's to create an integrated nervous system for global trade that the nation itself controls.
A nervous system. That's a great way to put it. And it has to be resilient and, as the brief says, ruthlessly efficient.
And to make that happen, the rotating master challenge focus, the thing that dictates the immediate workflow for the design studio, is structure.
Yes. And this is critical. They aren't asking for, conceptual sketches or pretty renderings. They are demanding high-performance structural engineering that anticipates failure and optimizes for speed and, importantly, lifecycle cost. This is where that abstract idea of sovereignty hits the concrete, literally.
Let's get technical in. What are the specific structural requirements they've highlighted that demand this high-performance focus?
Well, they're all-encompassing. The requirements span everything from massive viaducts for heavy rail all the way to complex coastal port works. They're demanding modular spans, which is really about speed and consistency in construction.
So you can build faster with fewer variables.
Precisely. They also demand accelerated bridge construction techniques, or ABC. This is all about minimizing disruptive closures. You can't shut down a city's main artery for 2 years to build a bridge. ADC gets it done in months or even weeks. And critically, this is a big one, they require fatigue-resistant details for elements that are under high cyclic loading.
Okay, let's break that down for our listeners. We're talking about the constant repetitive stress from, say, heavy freight trains running 24/7.
Exactly. It's essential when you have these heavy axle loads moving day in, day out.
And that fatigue resistance is so critical because, look, you can engineer for the maximum weight of the load, sure. But if you don't engineer for the repetition of that load over 20, 30, 40 years,
you're guaranteeing failure.
You're just guaranteeing massive, costly failures down the line. It's a ticking time bomb.
It is. And in the coastal areas, they get even more specific. They specify corrosion-proof systems. I mean, you have to think about the environment, the marine air, the salt spray, the humidity.
It just eats away at standard concrete and steel.
It destroys it. If you choose your materials poorly, the maintenance costs will completely erode the economic benefit of the entire port or viaduct system within a decade, maybe less.
And this brings us right to a core critique in the brief.
Yeah.
The structural choices must tie directly to lifecycle cost and maintainability.
Yeah.
You mentioned before we started that the choice between, say, a steel box girder and a precast U-girder isn't just an engineering choice. It's a fundamental financial one. Can you elaborate on that connection for us?
Of course. Let's take a port structure as an example. Say a wharf or a jetty. If we use a cheaper concrete mix that maybe isn't rated for a marine environment, it'll start to spall and corrode. You'll have to constantly do chloride extraction or patching just to keep it standing. The cost of that labor, the materials, and crucially, the operational downtime over 30 years, it will far, far exceed the initial savings.
So the smarter move is to specify premium materials up front.
Yes. Things like corrosion-resistant stainless steel cladding or specialized coatings or a higher-grade concrete mix. The brief is demanding that designers look at the total cost of ownership. It recognizes that high-performance, resilient structures are a non-negotiable part of achieving long-term sovereign prosperity. Why? Because they eliminate those unexpected, crippling budget drains later on.
So the lesson is crystal clear from page 1. Cheap infrastructure is just an operational liability dressed up as a capital saving.
That's the perfect way to put it.
All right, let's jump straight into the first pillar of this design mandate. Section 1. The West African Port Rail Integration Spines. This covers schemes 1, 3, and 9. And they are all about connecting these immense deep-sea ports to the dense urban centers and the necessary trade infrastructure behind them.
And we begin with a giant. Scheme 1, Nigeria, specifically the Lagos Port Rail City Logistics Spine.
The core challenge here is huge. It's integrating the Lekki DC port, which, to be fair, is a known success story, with the existing Lagos blue and red rail lines. And then there's the notoriously complex last-mile distribution across the city.
And Lekki is a massive operational precedent. You have to understand the scale here. It's built to handle about 2.5 million TEUs, that's 20-foot equivalent units, basically standard shipping containers annually.
But that efficiency at sea is only half the battle, isn't it?
It's not even half. The success of the port creates this corresponding pressure cooker on the landside logistics. I mean, think about it. If 2.5 million containers arrive efficiently at the port, but then get bottlenecked onto Lagos's already congested roads, you haven't solved a problem. You've just transferred it from the sea to the street.
You've created a logistical nightmare.
A total nightmare. So the goal here is to decisively decongest the roads, and the brief is specific. Design grade-separated freight spurs, get the heavy cargo off the road network entirely, and create what they call people-first interchanges.
The structural solution specified here is very telling. A steel box girder freight flyover. Now, this isn't a simple I-beam bridge. This is highly engineered. For our listeners who might not have had their hands on structural steel lately, why a box girder here? Specifically for this chaotic urban environment of Lagos.
It's a great question. The box girder is specified primarily for its superior torsional resistance and its stiffness. In a dense, built-up city like Lagos, these freight flyovers can very rarely take a straight path. It's impossible. They require tight curves, complex grade separations, just to weave through and bypass existing infrastructure and private property.
So they're twisting and turning.
Constantly. And when you have a heavy freight train, thousands of tons, moving at speed on a tight curve, the bridge structure itself experiences these massive twisting forces. That's torsion. A box girder, because of its enclosed shape, resists that twisting far, far better than an open I-beam configuration would.
So it guarantees stability.
It ensures stability, it minimizes long-term maintenance from stress, and most importantly, it prevents excessive deflection, which could actually derail a heavy axle load. So it's an explicit engineering solution to a highly constrained urban geography problem.
The structural choice is directly proportional to the logistical difficulty of the path. That's fascinating. But the brief offers a major caution here, and it's related to that successful precedent at Lekki. While the port is working, the Lagos blue and red rail lines famously faced long, painful delays. So the brief warns that risk management, things like interagency coordination and funding continuity, is absolutely crucial. And I have to ask, how can one design studio, even one as capable as KING-KAMBUF, possibly engineer governance stability? Isn't that asking the designer to solve a political problem?
That is the ultimate tension, right? It's inherent in all mega projects and complex governance environments. And you're right, you cannot engineer political will. It's impossible. But you can design the project to mitigate the consequence of political instability or those funding gaps.
How do you do that in the design itself?
Okay, so for example, by using highly modular structures, you allow the work packages to be broken down into smaller, bankable phases. Phases that can actually survive a short-term funding delay without compromising the integrity of the entire project. The structural specification itself, like the use of those standardized accelerated bridge construction techniques we talked about, that becomes a tool for financial resilience. You're essentially engineering around the risk, even if you can't eliminate the underlying governance complexity.
So the design forces a kind of discipline on the project management.
A physical discipline.
Yeah.
And their accountability is crystal clear. The deliverables have to quantify the TEU throughput, the mode shift percentage, that's freight moving off the roads and onto the rail, and the total truck kilometers avoided.
This is the very definition of the ESG angle, environmental, social governance. But it's not aspirational. It's measured in immediate, verifiable performance data.
And that's the only way it works. Now, moving southwest from there, Scheme 3 focuses on Côte d'Ivoire, the Abidjan Metro Plus Port Logistics Ring. This one pivots the focus slightly. While Lagos was all about heavy freight control, Abidjan is about integrating high-volume people movement with the port's operational needs.
The core requirement is that Metro Line 1 has to interface seamlessly with port logistics and bus feeders. This means you're building climate-robust viaducts and intermodal stations, often over existing, heavily constrained freight arterials.
Which creates a really unique engineering focus. They specify precast U-girders with seismic joints.
Okay, let's talk about that. Why U-girders specifically?
U-girders are excellent in dense urban environments because the sidewalls of the girder actually contain the track bed. This does two things. First, it significantly reduces noise pollution in residential areas, which is a huge quality of life issue. And second, it provides a much cleaner, safer structural profile than an open deck. It physically keeps pedestrians and debris away from the moving track.
And the seismic joints.
It's non-negotiable. Given Abidjan's location on a complex continental margin, designing for resilience against potential earth tremors is an absolute must. You have to build it to survive.
The precedent here, on paper, looks very strong. The brief highlights that the works are anchored by a major French consortium, Bose, Colas, Alstom, Keolis, and it even has a strict 66-month program. That looks bankable, it looks robust.
It does. On paper, it looks perfect. But the caution note is immediate, and it's sobering. It says that utility conflicts push the service start date out to 2028.
Wow.
Yeah. And this is the hidden enemy of all urban infrastructure. You can have a perfect contract, you can have world-class engineers, but the sheer complexity of relocating existing and often poorly mapped underground utilities.
Power lines, water mains, fiber optics.
That can halt billions of dollars of progress in its tracks. It just underscores that governance complexity often manifests not in high-level political disputes, but in something as mundane as a utility relocation permit.
So if Lagos is about achieving sovereignty through physical ownership of that heavy freight spine, Abidjan really shows that sovereignty is also about dignified, efficient mobility for the labor force that actually services that port.
Absolutely, 100%. Which then brings us to Scheme 9, Ghana, Timaport plus AfCFTA Trade House. This one feels like the direct realization of that whole logistics sovereignty mission statement.
This scheme focuses on what they call a diaspora-facing logistics campus. It's not just about Tema Terminal 3's massive throughput target, and it is massive. They're targeting 3.5 to 3.7 million TEUs. It's about linking that terminal directly to Accra's SMEs, small and medium enterprises, for trade under the AfCFTA.
And this is where the quality of the logistics defines the economic outcome. The brief isn't just asking for container yards. It demands seamless cold chain infrastructure, bonded mini warehouses, and dedicated green trucking.
This isn't just container staging, then. This is about value retention.
That's the heart of it. If Ghana owns the cold chain logistics, from the moment it comes off the ship, through the port to the SME, and out for final export, it retains more of the value from higher margin exports. We're talking perishables, pharmaceuticals, processed goods.
Instead of just exporting raw bulk commodities.
Exactly. So the cold chain infrastructure itself acts as a sovereign asset for economic diversification. It's a tool for moving up the value chain.
Okay, so structurally, what underpins that delicate high-value chain?
So the brief points to the cross-dock facilities. These are the buildings where goods are transferred quickly between transport modes, say from a refrigerated container to a smaller green truck. These facilities require a composite floor system to handle high live loads.
By live loads, that's different from just static weight.
Very different. This means a structural floor designed not just for something heavy sitting on it, but for continuous punishing dynamic loads. Forklifts, stackers, heavy pallet jacks, all moving quickly and constantly stopping and starting. If that floor fatigues or it cracks or fails prematurely, the cold chain breaks. The movement stops. And that SME's entire export opportunity just vanishes. The structural integrity is literally the backbone of the trade.
And the context here is crucial. The brief notes that the infrastructure is being built, but the AfCFTA rollout itself is still partial.
Right. So the success of this amazing physical structure still hinges on guided trade participation from member states and, critically, on customs modernization.
The structure enables the trade, but the policy and the customs systems have to be digitized and agile enough to realize that potential. It's a race between physical completion and policy readiness.
It's a classic chicken and egg problem on a continental scale.
We're going to shift now from those intensely integrated coastal spines to the massive inland and transborder challenges. This covers schemes 2, 4, 5, and 6. And this section is really dealing with vast distances, multiple borders, and the incredible complexity of moving goods and people across different sovereign territories.
We actually start with an urban solution, but one with huge regional implications. Scheme 2, Kenya, Nairobi, BRT plus clean bus depots. This is the urban decarbonization mandate, and it's focused on the BRT Line 3 spine.
The design challenge in Nairobi is, well, it's legendary. The brief says they need to deliver reliable, storm-safe elevated stations, and it specifies precast segmental median stations. But they have to build these within what the brief very frankly calls the informal urban fabric. This is not an easy task. You're navigating existing dense settlements, ensuring equitable feeder access.
All while developing these highly specialized depots that are designed for e-bus charging infrastructure. It's a multi-layered problem.
So why that specific structural choice? Precast segmental median stations.
It's a structural solution that is aimed squarely at minimizing disruption. Because the segments are manufactured off-site in a controlled environment and then just lifted into place, the construction time in the sensitive, busy urban median is drastically cut. And that's a critical factor when you're working in highly congested areas where every single hour of disruption has a measurable economic cost to the city.
The metrics for this scheme are also intensely focused on social impact. They're not just looking at capacity. They're measuring performance per person per day, or PPAPD. They're measuring crash rate reduction and charging kilowatt-hours per day for the e-buses.
It's financed via the city of Nairobi plus the EU Global Gateway. But the learning note here is sharp. The brief cautions that recurrent BRT budget issues and contractor risks are persistent problems.
So it's another warning to the designers. The brief says the design must rigidly lock the delivery sequences. What does that mean in practice?
It means you cannot rely on perfect contractual alignment or uninterrupted funding. You have to use the design documents themselves, the detailed phasing plans, the specified construction methodology to actually engineer the risk out of the sequence. For instance, the design can be set up so that if Phase A isn't finished perfectly to spec, the foundation connections for Phase B physically won't align. It makes it impossible to start the next phase incorrectly.
So you're forcing accountability through physical constraints.
Exactly. You're mitigating the risks of those stop-start funding cycles that can cripple a project like this.
Okay, next up is Scheme 4, and this takes us deep into the geopolitics of Southern Africa. We're talking about the SADC North-South Smart Corridor. This is the ultimate transborder challenge, upgrading multi-country freight and people corridors across the vast distances of the SADC region.
And the innovation here is all about digitized sovereignty. The mission is quantified, and I love the directness of this. Minutes, not days.
Minutes, not days.
That's the goal. They are designing what they call time-release border terminals and digital truck appointment systems. The whole idea is to completely obliterate the notorious multi-day border dwell times that act as this invisible, crushing tax on all SADC trade. This is a perfect example of where digital infrastructure must dictate the efficiency of the physical structure. The two have to work in perfect harmony.
Let's focus on that physical structure that supports the digital mandate. What exactly is a time-release border terminal, and how does that design actually achieve minutes, not days?
Well, the physical design of a time-release terminal has to align perfectly with that digital appointment system. It's not just about having an app. It means the terminal layout itself, the number of inspection bays, the configuration of the gates, the engineered flow of traffic. It all has to be optimized to measure and enforce the digital promise. The structure must physically eliminate any opportunity for queuing or for ad hoc informal processing.
Can you give us an example?
Sure. You could have a dedicated structural lane, a physical bypass, for trucks whose documents have been pre-cleared digitally. That alone could save 10 hours right there. The structural design physically removes the bottlenecks that the digital systems, on their own, cannot address.
And often this corridor requires strengthening existing assets. Right. The brief mentions a specific structural detail, the tide arch bridge retrofit. Why would you retrofit an old arch bridge instead of just building a new span from scratch?
Tide arch bridges are incredibly strong, but a lot of this existing infrastructure just wasn't designed for the immense, continuous, heavy axle loads that we see today with modern freight. A retrofit is a highly cost-effective intervention for these long corridor upgrades. By adding new strengthening elements, the tide arches to the existing foundation and deck, you can massively increase the load capacity and the fatigue life of the bridge.
Without the massive expense and disruption of completely replacing the substructure and closing the corridor for years.
Exactly. It's an intelligent, resilient way to upgrade these vital long-term corridors.
And the stakes were made incredibly clear by the Durban port crises in 2023 and 2024. Those events proved just how vulnerable the entire system is to extreme weather and to operational backlogs.
That's the anecdote that justifies the entire mandate. The failure of one key regional asset cascades across the entire SADC economy. The brief makes it non-negotiable. It says hardening equipment and operations is required for resilience. And this means specifying structural elements that can withstand climate events and operational backlogs. It's recognizing that climate change is now itself a structural design load you have to account for.
Wow. Okay, Scheme 5. This takes us to the economic engine of Central Africa, the Angola-DRC-Zambia Libido Minerals and Communities Corridor. This is the railroad port chain that connects the Copperbelt to Libido Port in Angola.
And this one is the ultimate balancing act. The corridor's primary economic function, let's be clear, is facilitating bulk mineral export. It generates massive wealth. But the design must explicitly balance that goal with social inclusion. It has to integrate local economies through secure yards, what they call village access nodes, and SME access lots.
How do you structurally mandate social safeguards? I mean, that sounds very abstract. How does a design team define a village access node to prevent the corridor from just becoming a giant exclusionary fence that bypasses local communities?
It's a great question because it's a real challenge. It requires integrating specific structural elements right into the right-of-way design. A village access node isn't just a sign, it's a structurally defined, low-speed interchange area. Maybe it uses specific paving materials or landscape design to calm traffic. It provides controlled, safe entry and exit points for local traffic and community members, preventing them from trying to cross the high-speed heavy-haul track directly. The whole design has to be audited not just for its engineering integrity, but for its sociological integrity.
And the cautionary precedent here warns that without that inclusion, the corridor can just bypass communities and actually make regional inequality worse.
Which has happened time and time again. And structurally, the heavy lifting on this corridor is immense. The brief requires heavy haul track slab details for those continuous mineral loads.
This is more than just standard rail ballast and ties, I'm guessing.
Oh, this goes far beyond that. Heavy haul track slabs are continuous concrete foundations that are laid beneath the track. They offer vastly superior stability, much reduced maintenance, and most importantly, superior load distribution for the immense, non-stop forces generated by these incredibly heavy mineral trains. If you tried to run that level of load on traditional ballasted track, maintenance would become a continuous crippling cost. It could potentially even cause the line to fail.
The financing is also really interesting here. It's layered, AFC and DFC finance with U.S.-backed upgrades de-risking the capital stack. This is high-level geopolitical financial engineering supporting the physical engineering.
Absolutely. And finally in this section, we have Scheme 6, Ethiopia-Djibouti, Railway plus Dry Ports 2.0. This is really a story about an operational turnaround that's being driven by physical modernization.
The focus here is on increasing locomotive availability, redesigning the yards for efficiency, and renewing the catenary system that powers the electric trains. They need to shift from just operating a line to optimizing an entire logistics value chain.
And the structural detail they call out here is hyper-specific, but it's all about operational uptime. Fatigue-rated gantry crane footings.
Okay, why is that one structural detail so important?
Because the dry ports are the engines of trade for a landlocked country like Ethiopia, and the cranes are the pistons in that engine. Gantry cranes impose these massive, repetitive, dynamic loads every time they lift and transfer a container. Those footings, the concrete bases, have to handle that constant cyclical stress without developing microcracks or settlement issues. If a footing fails, the crane is down, and when the crane is down, the entire logistics engine for the country just stops. Specifying a fatigue rating is an explicit acknowledgement that the ground infrastructure needs to match the performance capability of the modern lifting equipment you put on top of it.
The precedent here is really a story of success battling against caution. The railway reported its first profit milestone after some major performance reforms, which is a huge governance win.
It's a massive success. But it still suffers from fleet constraints and undercapacity, and the brief says this is due to deferred maintenance.
So it's the classic infrastructure trap.
It really is. You achieve financial success through operational excellence, but you are constantly fighting the physical legacy of past neglect. This design brief is aimed squarely at stopping that cycle of deferred maintenance by specifying robust, fatigue-resistant structures and systems right from the start.
Okay, let's move to our final geographic section. This is schemes 7, 8, and 10. And this really highlights the KING-KAMBUF ambition to integrate the diaspora directly into the infrastructure network, often using highly advanced systems or tackling unique challenges in very mature logistics environments.
We start with Scheme 7, which brings us to Morocco. Tangermed plus Casablanca Clean Mobility. And Tangermed, you have to understand, is already a global top performer. It doesn't need basic capacity upgrades. It needs seamless integration.
So the challenge isn't moving containers, which Tangermed does expertly. The challenge is tying this massive industrial zone, a huge employment hub, to urban clean transit for labor mobility.
It's about decarbonizing the daily commute for thousands and thousands of workers. It's that mobility is power idea again, but this time it's for the workforce.
The structural solution proposed is elegant. It's designing worker shuttle BRT and tram interchanges. And the specific detail they call out is corrosion-resistant steel canopies for the intermodal stops.
Now, that might sound like a minor detail, a cosmetic choice.
It does a little bit, yeah.
But in a harsh marine industrial environment like that, poorly chosen canopy materials will quickly degrade. They'll rust, they'll become eyesores, and they become a constant maintenance burden. By using corrosion-resistant steel, you ensure the longevity and the clean aesthetic of the transit infrastructure. And that reinforces the public perception of a high-quality, modern, sovereign system. The details matter.
But the caution note here is important. It emphasizes the challenge of growth. The rapid expansion of Tangermed, including the new Nador West Med port, requires continuous, relentless capacity planning. These ports are massive capital sinks.
They absolutely are. Once you achieve that global top-tier status, the demand for continuous, multi-billion-dollar investment to maintain cutting-edge efficiency never, ever ends. The structural designs have to be inherently adaptable to future, currently unknown, technology upgrades and capacity expansions. You have to build for a future you can't even see yet.
All right, Scheme 8 is truly unique. It directly addresses that diaspora element of the mission. It's USA, Savannah Appalachian Inland Rail for Diaspora SMEs. This is about physically plugging African diaspora import-export small and medium enterprises directly into the massive U.S. logistics network.
This is logistics democratization, and it's being structurally enforced. The goal is hyper-specific. It's about ensuring that the small players have real, tangible access to the scale of the Savannah Rail and Inland Port Network. Historically, small players are marginalized by the sheer volume and complexity of major U.S. logistics hubs. They can't meet the minimum volume requirements, they get lost in the customs bureaucracy, the warehousing costs are prohibitive.
So the design deliverables are meant to address this marginalization directly. The brief calls for a micro-fulfillment and trade house network, including what they call customs brokerage pods. This is logistics designed for a human scale, not just a container scale.
And the structural detail for these trade houses is fascinating. They specify long-span, cross-laminated timber CLT roofs for flexible bays. We really need to unpack this choice.
Yeah, please do.
So CLT is sustainable. It's a green building material, which is great. But more importantly for logistics, long spans mean minimal internal columns.
Okay, and why is that so essential for an SME fulfillment center?
Because their business is all about agility. Their inventory changes constantly, their needs change, their stacking layouts have to be reconfigured on a weekly, sometimes daily basis. A long-span CLT structure allows them to rapidly reconfigure their entire interior space without being constrained by fixed structural elements like concrete columns. The structure itself facilitates maximum business flexibility.
The structure supports the business model. And the resilience context here is global. The design has to include diversification and buffer yards because disruptions on the other side of the world, like the Red Sea crisis, they cascade all the way across the U.S. networks. You have to build in that redundancy.
Yes, you do. And finally, Scheme 10 takes us to the Caribbean diaspora, focusing on Barbados Bridgetown Port split ops.
The conflict here is a classic one for the region, but it's particularly acute in Barbados. It's massive cruise tourism versus vital cargo flow. The design mandate is explicit. They have to separate the cruise and cargo flows to protect food imports and diaspora trade. And they specifically want to avoid what they call no cargo days during the peak cruise seasons.
You cannot afford to halt food and goods delivery because a cruise ship is in port. That is a sovereignty issue in its purest sense. We're talking about food security and economic stability.
The technology focus is on modernization, adding new electric ship-to-shore, STS cranes, and shore power-ready designs to reduce emissions.
And structurally, the absolute key here is the STS crane beam and its tie-down structures. These are the elements that physically anchor those massive multi-story cranes to the pier.
Given that the region is hurricane-prone and the dynamic loads from the cranes are immense, why is the focus on the tie-down structures so critical?
Well, the dynamic loads alone are incredible. The sudden acceleration, deceleration, and braking of the crane, while it's holding a fully loaded container, it generates these incredible forces on the foundation. But in Barbados, those structures also need to be engineered to survive seismic events and, crucially, hurricane force winds. They act as the critical tie-down that prevents the multi-million-dollar crane from being damaged or completely destroyed in a storm. The integrity of that single structural detail determines the entire port's operational resilience post-disaster.
And the implementation complexity, they note, upskilling the crane technicians, coordinating dedicated cargo berths, it just proves again that sovereignty requires highly trained human capital and hyper-precise scheduling just as much as it requires concrete and steel.
It's always a synthesis of the two.
So we've dissected 10 massive high-stakes schemes. Now let's look at the operational reality for the designers themselves, the execution mandate. This section really reveals the immense pressure and the rapid synthesis required by the KING-KAMBUF studios.
The instructions are intense. They enforce this demanding two-tiered approach. Designers have to select one short study. These are the more focused projects like the Nairobi BRT or the Ethiopia-Djibouti Railway or the Savannah Inland Rail.
Okay.
And then they have to select one long commission-style project. These are the vast, complex corridors like the Lagos Port Rail Spine, the SADC Smart Corridor, or the Morocco Port City integration.
So this forces them to demonstrate mastery across scale. They have to jump from a hyperlocal detail to the transborder complexity all at once.
Precisely. And the time frame is immediate and frankly brutal. They have a 90-minute concept block.
90 minutes.
90 minutes. And in that hour and a half, they are not just sketching. The brief requires them to draw the system diagram, map the intermodal nodes, and define the entire structural system span type materials corrosion class. This demands immediate, informed, and precise technical decision-making under extreme pressure. There is absolutely no time for generalities.
And they have to quantify performance in that concept stage. It's not just drawings. The required output is data. Quantified dwell time, PPHPD, TEU per hour, truck kilometers displaced.
This is where the tension is highest. They have to rapidly synthesize complex logistics analysis with structural feasibility. The design has to be measurable before it's even rendered. If your concept doesn't show a verifiable reduction in dwell time, it fails a mandate, period. Doesn't matter how beautiful the drawing is.
So the concept block is about rapid synthesis and quantification. Then comes the next stage, the 90-minute drawing detail block. This is where they have to prove the concept is actually buildable.
And precision is everything here. They need to produce plan and section drawings at specific, large scales. 1 to 2,000 for the overall context, 1 to 400 for key systems. Plus, they need one crucial structural detail, something like that precast U-girder connection we talked about, or the cross-laminated timber roof assembly. This exercise forces the designer to seamlessly jump from the multi-country 30,000-foot view right down to the millimeter precision of a structural connection. It confirms they understand the buildability and the material science required to make it real.
This inherent tension between the rapid synthesis in the first 90 minutes and the highly detailed precision in the second 90 minutes, that feels like the core of the KING-KAMBUF workflow.
It is. It forces designers to think like strategists and engineers and contractors, all simultaneously. And the physical outputs, what they call the boards, also reveal the communication strategy. They require 2 A2 boards for the technical rigor, the vision, diagrams, and details. But they also require 1 A3 board that's just a public communication graphic.
Because these projects need more than engineering excellence. They need public buy-in and clear political communication to secure that all-important funding continuity.
Absolutely. The working method also focuses heavily on data and metadata archiving. Every single project must be cataloged under specific fields. Theme, focus, which is structure in this case, scale, from object to transborder systems, and ESG impact. They're building this massive, accessible institutional knowledge base across Africa and the diaspora.
And the required post-crit reflection, what they call the lesson learned, is maybe the most revealing requirement of all.
I agree. They want actionable, quantified insights. The example they give is time release plus reliable cranes beat asphalt in cutting dwell time.
That's powerful. It elevates operational and digital efficiency above just raw physical construction.
It confirms that the physical structure is merely the substrate for sovereign logistics. The true power lies in the systems that govern the flow of goods and the maintenance of the assets.
And the final output has to be a publication-ready brief in that signature KING-KAMBUF style. Quantified callouts, short checklists, and narratives that are anchored explicitly in the AfCFTA and Agenda 2063 frameworks. It's technical documentation wrapped in a strategic mission narrative.
Which brings us, finally, to the KING-KAMBUF closing directive. This is the philosophical foundation that ties all 10 of these massive schemes together.
It's the ultimate statement of purpose, isn't it? Mobility is power, logistics is sovereignty. The mandate is to design structures and systems that aggressively cut days to minutes, waste to value, and distance to opportunity. And this mission spans KAMBUF across the entire continent of Africa and the diaspora.
And the final command is just stark, powerful, and utterly clear. It leaves no ambiguity about the scale of their ambition. Build the corridor, on the flow, expand the nation. So, when you pull it all together, what this command brief really reveals is that nation-building infrastructure today is defined by integration. It's not just about one thing. The structural challenge is paramount, of course. The choice of a fatigue-resistant box girder or a heavy-haul track slab, that matters deeply. But these physical assets have to be perfectly integrated with all the invisible systems.
The logistics software, the governance structures, the digital appointment scheduling,
and the layered finance solutions. The real complexity comes from blending that global finance, from the AFC, the DFC, the EU Global Gateway, with these hyper-local sensitive issues like guaranteeing SME access lots or navigating through informal urban fabric.
The integrity of single structural detail is a direct function of the geopolitical and trade ambition of the entire nation. The quality of a precast U-girder connection or an STS crane tie-down, that literally dictates the speed and dignity of movement for goods and people.
And that, in turn, secures the sovereign prosperity of the city-state or the region. This document is just an extraordinary, detailed blueprint for translating these abstract, massive economic goals into quantifiable, highly technical engineering challenges.
The design studio isn't just drawing lines on a piece of paper. They are actively shaping the future of African and diaspora trade. They are designing structures to achieve economic freedom.
That's the endgame.
So as you, the listener, reflect on this massive analysis of the KAMBUF National Building Design Command Brief, I want you to consider the consequence of failure. If logistics is sovereignty, what happens to the regions or the city-states where this crucial design integration fails? What is the unseen cost when control over goods and mobility is outsourced, or when chronic congestion just acts as a permanent debilitating tax on all trade? That is the scale of consequence embodied in this brief.
And perhaps the most provocative thought to leave you with is to consider the long-term cost of that deferred maintenance we saw referenced in the Ethiopia-Djibouti corridor. If a structural choice sacrifices resilience for a short-term cost saving, you are essentially pre-programming systemic failure into the network 10-20 years down the road. The cost of future operational constraints, of fleet failures, of underperforming ports, that is the invisible price that is paid for a lack of design continuity in a long-term corridor. What happens when engineers decide to build for political cycles rather than for economic centuries? That is the ultimate question this command brief attempts to solve.